Hi, it's Mr. Piercy here. Today we're going to be looking at investigating transformations of curves. And in particular, we're going to be looking at a simple quadratic curve, f of x equals x squared. A transformation can be done algebraically and graphically as well. So, for example, if I wanted to transform this particular curve, I could add something to it or take away something from it. So, for example, let's say if I add 2 to both sides of this equation, then I've transformed the curve. And what we're actually going to be looking at today is we're going to be looking at what happens graphically when you actually add or take away a number from this equation here. So let's get on to GeoGebra and let's have a look to see what happens. As you can see here, I've got f of x equals x squared. Please try and ignore the zeros there. But it is definitely f of x equals x squared, because when x is 1, then f of x is 1. 1 squared is 1. When x is 2, then f of x is going to be 4, because 2 squared is 4. So it's definitely the curve x squared. And if you look to see what happens as I move this slider, you can see that the curve is actually moving up and down depending on whether I add a number to the curve or whether I take away a number from the curve. So if I leave that just on around 2 at the moment, it's actually on 1.9 now, you can see that when I've added 1.9, the curve has moved upwards by 1.9 units. If I say change that to say 1, you can see that the curve f of x has moved upwards by 1 unit. If I make it negative, so if I take away a number, then you can see how the curve has moved downwards by 2.3 units there. So you can see the movement happening. It's quite a simple movement, really. If I go back onto Paint, let's try and explain that movement. Well, mathematically, that movement has got its own key word, and that key word is a translation. So a movement of a curve on a coordinate grid is called a translation. Okay? However, we do know that this particular translation, this takes the curve 2 units upwards. And to describe that, we use something called a vector. And this particular vector has 2 components. The first component tells you how far the curve has moved left or right. And the second component obviously tells you how far the curve has moved up or down. So in our case, the curve actually moved 2 up. It didn't move any left or right, so it moved no units left and right, and it moved 2 up. Let's have a look at another example. If, for example, I had f of x minus 1 equals x squared minus 1, then again that's going to be a movement, it's going to be a translation. And that's actually going to take the curve 1 unit downwards, as we saw in GeoGebra. So again, it's not going to go any across, no movement across, but it's going to go 1 down. And to represent that, we're actually going to write a minus 1 to represent a downwards movement. Okay? So now we've done that, I guess we could do it in general for, say, f of x plus k, for any number, f of x plus k. So that is again going to be a movement, it's going to be a translation. But again, that's not going to move the curve any units left or right. That's going to be 0. But if I add k to the curve, then that's going to move upwards by k units, or if k was a negative number, it's going to move downwards by k units. So this is a translation of 0 k. So I hope that helps with translations. I'm going to put up a video shortly on more translations and more stretches. Thanks a lot. Bye.